All right, so here's section B5, part 2. So now we're going to go on and we're going to do some subtraction. So if I'm going to subtract, again, I need a lowest common denominator. So the first thing that I'm going to do here is I'm going to factor each one of the denominators. Remember I said earlier that factoring is probably the most important thing that you learn in Math 53. So now this was actually a perfect square. So I'm going to write this as a perfect square because that's going to become important as we find our lowest common denominator. So our lowest common denominator would be x minus 4, and it would be x plus 4 squared. We would need both of these x plus 4s. Remember, the lowest common denominator would be the smallest expression that both of the denominators divide into. So this divides into here evenly. And do you see where if I didn't have this squared here, if it was just this as the lowest common denominator, this does not divide into there evenly. You need the highest exponent. So if we go ahead, so let's see, we have 2x times x plus 4 times x minus 4. We're going to have to multiply top and bottom by what's missing. If I need this to look like my LCD, well, it's going to be another x plus 4. Minus 3 times x plus 4 squared. So we're going to have to multiply top and bottom here also by something. Well, what's missing? It looks to me like it's x minus 4. I'm worried I'm going to run out of room here. So let's see. Let's distribute here. So if I distribute, I'm going to get 2x squared plus 8x. Now I'm going to take, and remember this is subtraction, so I'm going to distribute through a negative 3. So it's kind of like taking subtraction. Remember back in the day in Math 47, how subtracting is really adding the opposite? So we're going to end up distributing a negative 3. So it's going to be negative 3x plus 12. And I'm going to get lazy here and just put that over the LCD. So combining like terms, I get 2x squared plus 5x plus 12. And that's going to go over x plus 4 squared times x minus 4. So now the last thing to do would be to figure out if this reduces. Is this going to factor? Well, I can tell you right now, you could try and try and try, but this is not going to factor for you. So this is our final answer for C. All right, let's look at D. I know D is not going to take that much room. So you can see that if you look at the denominators for D, they're almost the same, aren't they? They're not quite the same, but they're almost the same. And in fact, what I could do is if I could factor a negative 1 out of either one of these denominators, it would flip it and it would make them be the same. So that is what we want to do. Now the key is, what do you want to do with that negative 1? Now remember, a fraction, that negative, if it's a negative fraction, can go anywhere. So for example, one thing I could do is I could factor a negative 1 out of this denominator. And what would I do with that negative 1? I could make this a negative 8. I could factor a negative 1 out of this denominator. And I could do one of two things. I could factor the negative 1 out of here, which would make this a negative. Or I could factor the negative 1 out of this denominator, which would change this from a negative to a positive. Any one of those 4 things that I just mentioned to you will give you the exact same answer in the end. So it's really kind of up to us. I tend to like to factor the negative 1 out of the second denominator and change this to a positive. So let's look at that. That's going to give me So now again, I'm going to factor a -1 out of here. So here's what it's going to look like. And now again, that -1, I can put it up here and make that into a -2, or I could put it here and make that into a plus, which is what I am going to do. Which would give me, for a grand total of an answer, 10 over 3 minus 7y. If you look, if I had just made this a -2, we would have ended up with 8 minus -2, which is still 10. So you're still going to get the same answer. All right, now I would suggest for E, maybe you pause the video and you go ahead and do it and make sure we get the same answer. I'm going to go ahead and do it now. So the first thing that I'm going to do is I'm going to factor all of the denominators. So here I can take out an r. I can take an r out of the second denominator as well. Now the third denominator is a trinomial, so I'm going to backwards FOIL. And it's going to be r, and it's going to be a +2 and a -1. So my lowest common denominator would be r times r plus 2 times r minus 1. So if I rewrite this first fraction, I have to multiply top and bottom by what's missing to make it into the common denominator. So that's going to be an r plus 2. Rewrite the second fraction. Do the same thing, except this time missing would be an r minus 1. And then do the last fraction. And having to multiply that by an r over an r. Now all the denominators are the lowest common denominator. So let's go ahead and let's combine these things and distribute. So we're going to have 4r plus 8 plus, because it's addition, 6r minus 6 and then minus r all over that lowest common denominator. Combining like terms, let's see, I have 4r plus 6r is 10r minus r. I would have 9r. And then 8 minus 6 is plus 2 over r times r minus 1 times r plus 2. And nothing can be done to factor, so there's no canceling to be done. Hopefully that's the answer you got. All right, so now it's important that you understand the difference between addition and subtraction and solving an equation. And solving equations are our last 3 examples that we are going to do here. When you solve an equation, you again want to find the common denominator. So the first thing that you're going to do for this first problem is factor all of the denominators. So my lowest common denominator, hopefully you see, is m plus 2 times m minus 2. Now what we do with it is different than what we did when we were adding and subtracting. We need to use that common denominator to eliminate the fractions. So what we need to do now is we need to multiply every term by this common denominator over 1. And that will eliminate the fractions. Because look, if I do this first term, it's got to be done to all 3 terms. If I do this first term, you can see that everything cancels. This is in the top and this is in the bottom, which leaves me with simply 2m plus. If I do this fraction right here, you can see that the m minus 2's cancel. And what is that going to leave me with? Simply m plus 2. Equals, if I go to this last term, you can see the m plus 2's cancel, which will leave me with 2 times m minus 2, and you can see that the fractions are gone. Now I just solved this, so I'm going to get 3m plus 2 equals 2m minus 4. So if I subtract 2m from the left-hand side, I'm going to get m equals, subtract 2 over here, m should equal -6. So you still find the lowest common denominator, but you use it to then eliminate the fractions when you are solving an equation. Something similar is going to happen here. So let's go ahead. I notice that this third fraction, the denominator, is going to factor. So you should be able to see that your common denominator is 2 times x minus 1 times x plus 1. So we're going to go ahead and we're going to multiply everything by 2 times x plus 1 times x minus 1 all over 1. All right, well, let's see what's going to happen. When I do this first term, only the x minus 1s are going to cancel, which is going to leave me with 2 times x plus 1 plus. When I do this second term, only the 2's are going to cancel, and that's going to leave me with x plus 1 times x minus 1. And finally, when I do this term on the right-hand side of the equal sign, both the x plus 1 and the x minus 1s will cancel, which leaves me with 2, this 2 times that 2. All right, well, this is going to take a little bit more work. We're going to distribute. Here you can see we're going to have to FOIL. That's going to be x squared minus 1. And, of course, 2 times 2 is 4. Now, we have an x squared in our final equation. That's a quadratic equation. How do you solve a quadratic equation? Hopefully you remember that. You bring everything over to one side, set it equal to 0, and you factor it to solve. So let's see, I'm going to have x squared. If I combine, well, the 2x is just going to stay. If I combine 2 minus 1, that's going to give me a 1. Now I need to subtract 4. Now I have to factor this. So I'm going to get x plus 3 and x minus 1. And if I take each of these factors and set it equal to 0, I get two solutions. I get -3 and I get +1. Now, one last thing. When you have a rational equation, there are times when a solution will not check. The only time that a solution will not check is if when I plug that solution back into a denominator, it gives me a 0, because of course you can't have a 0 in the denominator of a fraction. Do you see that if I were to take this solution x equals 1, and if I were to plug a 1 in here, it would give me 0 in the denominator? Can't have that. So what we do is we toss that answer, and there's one solution to this equation, and it is x equals -3. All right, we have one more problem to do in this section. Again, I would, if I were you, pause the video. I think you should have the idea here, and I would do it on my own. I'm going to go ahead and do it. So the first thing that I'm going to do is factor the denominators. Take a 2 out here. Take a 4 out here. So my lowest common denominator, well, I would need a 4. A 2 isn't big enough. I'd need 4 times x plus 1 times x plus 3. And remember what I do with that. I'm going to go ahead and I'm going to multiply every term by that lowest common denominator to help me cancel out the denominators. So if I do this first term, x plus 1 and x plus 3 are going to cancel, and I'm left with simply 4 times 1, which is 4. Here, the x plus 1s are going to cancel, and the 2 will cancel into the 4, leaving me with a 2. So I'm going to have 2 times 1, or 2 times x plus 3 left. And if I do this last fraction, multiplying it, the 4 cancels, the x plus 3's cancel, and I'm left with the 3, this 3, times x plus 1. And now it's just a matter of solving this old-fashioned equation. So I'm going to distribute, combine like terms. If I subtract 3x, I'm going to get negative x, and then subtract the 10 equals negative 7. X is equal to 7, which does not give me a 0 in any of the denominators, so x equals 7 is my final answer. And I think that's the end, of B